Have you ever imagined an AI that can handle all your tasks with just a simple text? Well, buckle up because I'm about to show you a demo that will blow your mind. Introducing Brian AI, the ultimate automation tool that understands your command and get things done for you in a jiffy. Let's say you want to watch the Interstellar movie on Netflix. All you have to do is text Brain AI and tell it what you want. It will quickly analyze your request and locate the appropriate URL. Once it knows where you are at, it will search the GPT database and works its magic to get you what you need. And voila, Interstellar will be playing on your screen before you know it. Now, let's dive into the nifty-gritty of building this incredible app. First up is we need to set up the development environment using a Webpack. We'll start by creating a file called webserver.js and configuring 3 environment variables that controls how Babel and other tools behave during this build process. Next, we'll import all the necessary dependencies, load the Webpack and environment configurations. We're going to enable hot reloading of our web application's code. So we'll set up a Webpack dev server instance with all the necessary options. We'll modify the entry configurations of the Webpack configuration to add 2 entries to the beginning of the array for each entry point. These entries will enable hot reloading functionality for the Webpack build process and instruct the Webpack dev server to connect to the server running on localhost at specific port and enable hot reloading for the served assets. We're not done yet, folks. There's still more to build this amazing web application using Webpack. Let's talk about the hot module replacement plugin, which is a real game changer. This plugin allows us to replace modules that have been modified during the build process without having to reload the entire page. That's right, we can make changes on the fly without any interruptions. Once we have added the plugin to our list of plugins, we'll create an instance of Webpack dev server using the options we configured earlier and start the server. Now let's talk about the env.js, a file that's crucial to our application's environment. Inside env.js, we'll import an object with 2 properties, node env and port. These properties provides default values for 2 environment variables. The node env property sets the environment in which the application is running, whether it's productive version or development version. If the node env environment variable isn't set, it defaults to development. The port property specifies the port on which the application should listen for incoming request. If the port environment variable isn't set, it defaults to 3001. Why is this important? Well, by setting up these default values, we ensure that the application has the necessary environment variables set, even if they aren't explicitly set by the user. This is particularly useful in situations where you need to set the environment variables for your application, but don't want to rely on the users to set them every time they run the application. Alright, let's dive into the process of setting up the environment variables for a production build of our application in build.js. First up, we need to set the Babel env, node env, and asset path environment variables to the production, which tells the code to optimize for the production use. To do this, we'll import the Webpack module and the webpack.config file, which contains all the necessary configuration settings for the Webpack build. After that, we can safely remove the Chrome extension boilerplate property from the Webpack configuration object, since it's not needed for the production build. Finally, we'll set the mode property of Webpack configuration object to production. This tells Webpack to optimize the code by minimizing its size and removing any unnecessary codes. All in all, these steps ensures that our application is running effectively and smoothly in production mode. Alright, so now we are getting into the actual app building phase. The first thing we need to do is create a manifest.json file in the src folder. The file contains some basic JSON data that specifies where and how the app will be used. Once that's done, we can move on to the next file called constant.ts. What's happening in constant.ts is that we are defining 2 constants using JavaScript constant keyword. The first constant, brain element selector, is being set to equal to string data brain node id. This is just a simple string that will be used later in the app. The second constant, debug mode, is a bit more complicated. It's being set equal to the result of a comparison between the value of a specific environment variable, process.env.debug mode, and the string true. For those who might not familiar with it, the process.env is an object in JavaScript that holds an information about the current environment. In this case, the code is checking the value of the debug mode environment variable to see if it sets to true. If it is, then debug mode is set to true, otherwise it is set to false. Finally, both of these constants are exported using the export keyword, which makes them available for use in other parts of the code base. This allows other modules and functions to access the brain element selector and debug mode constant and use them in their own code. And then we're going to be creating a new file called current.task.ts, and in this file we're just exporting a function called createCurrentTaskSlice, which returns a current task slice object. The current task slice interface defines the shape of an object that has various properties and methods such as table, instructions, history, status, action status, and actions, among others. Create current task slice is a function that takes 2 arguments, set and get, which are functions from a state management library that allows for updating and retrieving the current state of the application. Inside the create current task slice function, the initial state of current task slice is defined and written along with the two methods. Run task is an asynchronous function that takes on an error function as an argument. It first checks if there are any instructions and if the task is not already running, and then sets the status to running and action status to attaching debugger. Next, it attempts to attach a debugger to the active tab and disables any incompatible extensions. It then enters an indefinite loop performing various actions such as pulling the DOM, transforming the DOM, performing query, performing an actions, and waiting. If an error occurs at any point, it sets the status to error. If the action is successful, it sets the status to success. And we're going to define an interrupt method which just simply sets the status to interrupted. In settings.ts, first up is importing the statement, bringing in a module called myStateCreator from the store.js file. Next, we have a definition of a TypeScript type named settingSlice. This type has three properties: OpenAI key, selected model, and action. The OpenAI key property is a string or null. Selected model is a string, and action is an object that has one property named update. The update property is a function that takes arguments named values, which is a partial type of a setting slice. Moving on to the create setting slice constant, it is being assigned a function that takes one argument called set. This function returns an object that confirms that setting slice type. The OpenAI key property is set to null. The selected model property is set to the string GPT 3.5 turbo. And the action property is an object that has one property, update. This update property is assigned a function that takes an argument called values. This function uses this set function passed in an argument to update the state object. The set function takes an callback function that gets passed in the current state object, and it returns a new state object that is merged with the previous state object. In this case, the previous state object is being merged with the values argument passed into the update function. The syntax is used to spread the state.settings object and the values object, effectively merging them together into a new object. In store.ts, we start by importing several functions from different packages that we'll use later in the code. For instance, we import merge from the Lodash package, which is a popular utility library for JavaScript that provides functions for common tasks like manipulating the objects and arrays. We also import create and state creator from the SysStack package, which helps us to create and define application state. Moving on, we define a type called store type that represents the overall structure of an application state. This type is an object that contains three properties: current task, UI, and settings. Each of these properties has its own type, such as current task slice for current task. After that, we define another type called myStateCreator. This is a generic type that represents a function used to create a new state. The type takes four type parameters: store type representing the overall structure of the application state, an array of middleware functions we'll use later, an empty array, and the type of a new state. So in store.ts, we're setting up the application state. We start by using create functions to create a new store with an initial state that's an empty object. Then we pass this store through a bunch of middleware functions to add more functionality. The first middleware we add is immer. This middleware allows us to write code that updates the state in a more declarative way, even though we are using mutable syntaxes. Then we add the DevTools middleware, which enables us to use the process DevTools to debug the application state. Next, we add the persist middleware, which lets us to save some parts of the state to local storage. This can be useful for saving users' preference and other settings. We specify which parts of the state to persist and give a name to the local storage key. Finally, we set up the initial state of each part of the application state using the function like create current task slice, create UI slice, and create setting slice. These functions return an object representing the initial state for each part of this application state. Towards the end of the state, we export a hook called useAppState, which allows us to access the application state. We create this hook by calling create with store type and passing it through all the middleware functions we defined earlier. Lastly, we define a global variable called window.getState, which can be used to access the application state for debugging purposes. Okay, so let's talk about the UI.ts. Here, we're going to be defining a thing called UI slice, which is like a part of a state of the app that's all about the user interface. We're going to make a function called create UI slice that creates the UI slice thing. The UI slice itself has two parts: an instructions field that's a string with some instructions for the user, and an action object that has functions called setInstructions. This function is used to update the instructions field when something happens in the app. When we call the create UI slice function, we give it a parameter called set, which is used to update the state of UI slice. Then the function returns an object that has an initial value for the instruction field, which is null to start, and an action object that has set the instruction function. When set instructions is called, it updates the instructions field by using the set function we gave it. This function takes a callback function that gets the current state and returns a new state. So in this case, the callback function just sets the instruction field to whatever value was passed inside a parameter. This whole UI slice thing is just one part of a bigger state object that represents the entire state of the app. We can combine different slices like this to make a bigger, more complex state object that represents everything that's happening in this app. Helper functions play a crucial role in communicating between different parts of an extension. For example, they enable us to send messages between the background scripts and content scripts, or between different content scripts. They also allows us to manipulate the DOM by injecting CSS or JavaScript into a web page, or reading and writing data from HTML elements. Furthermore, helper functions help in handling events like listening for clicks or other users' interactions, or responding to page load events. To make the code more manageable and avoid repetition, I have already built many helper functions for different extensions, and will only need a few of them for this app. The main part of building this app was designing the entire UI, which took me some time to create. You can check out the source code to see how it works. Now it's time to test the app. You can access the extension by clicking on the link I'll provide in the description. You can download the extension from the blog and use it with ease. So let's get started. Let's say you want to watch Interstellar movie on Netflix. All you have to do is text Brain AI and tell what you want. It will quickly analyze your request and locate the appropriate URL. Once it knows where you are at, it will search the GPT database and works its magic to get you what you need. And voila, Interstellar will be playing on your screen before you know it. Well, that's pretty much it. I'll catch you guys in the next video. Peace.